The original Star Wars trilogy, released between 1977 and 1983, fundamentally changed how many people viewed space technology and warfare. However, some of the most memorable moments rely more on creative storytelling than actual science. Today, we will separate the cinematic fiction from the scientific fact. To start, let us explore conflict in space. The first main issue is that space is a vacuum, so there are no particles. Therefore, sound cannot be transmitted, and combustion, explosions, cannot take place. Furthermore, astronauts, when they accelerate from stationary to thousands of kilometers an hour, should have severe injuries or even death, because G-force can still occur in space. To explain this, the producers introduce inertial dampeners, which use artificial gravity technology to keep astronauts on the floor of their spaceship and also counteract the huge forces of G-force. Next, personal weaponry. Blasters in Star Wars are shown as shooting slow-moving, coloured lasers. However, a real laser would be more like a silent, instantaneous beam. The only possible option is that projectiles in Star Wars are more likely to be made of plasma. Plasma is a superheated, ionized gas and is often called the fourth state of matter. Plasma can also fry human tissue at the atomic level. Next, lightsabers. Lightsabers are even harder to explain with real-world physics. They appear as solid, meter-long blades of light. However, light cannot stop at a fixed distance without a physical boundary. This again hints towards plasma. Plasma, like in a nuclear fusion reactor, can be magnetically confined to stay in a certain shape. It also has huge energy densities of up to 108 joules per meter squared to cut through steel. The Death Star is shown as destroying a planet, Alderaan. However, to destroy an actual planet, a spaceship would need up to 2 × 10 to the power of 32 joules, which is equivalent to many days of the sun's energy. However, if we presume that the people in Star Wars have mastered the art of nuclear fusion, they could create enough energy to shoot a massive laser beam and destroy a whole planet. Now, hyperspace travel. The main issue with hyperspace travel is it clearly violates Einstein's law of general relativity, that states that due to time dilation, for an object to reach the speed of light, you would need an infinite amount of energy. Star Wars fans have come up with 2 options to explain this. The first is that the jump into hyperspace is in fact the entering of a new compressed dimension. In this dimension, you would only have to travel a small distance and then re-enter the other dimension and have travelled a long way. The next option is using warp drives. Although these are not possible as of today, they could in the future play in to colonising new planets. Warp drives can bend the space-time continuum and therefore allow for spaceships to essentially skip distance and enter and re-enter time in a different place. In terms of celestial bodies, Star Wars is often scientifically accurate. Tatooine, the home of Luke Skywalker, is known for its 2 suns, which characterize the binary sunset scenes. In fact, this is entirely possible with 3 different orbital options. In a binary system, 2 stars follow elliptical orbits around a common center of mass, and around each star is an invisible boundary in which all matter and gas gravitationally belongs to that star. This area around the star is called a Roche lobe. Now we shall explore the 3 different types of binary star systems. The first is detached binaries. In detached binaries, neither star's Roche lobes interact, and therefore no gas or plasma is transmitted. These are the most common in our universe, so it's probably the most possible option for Tatooine. The next is semi-detached binaries, where one star can completely fill or overflow its Roche lobe, and therefore donating matter and plasma to the other star. These form about 20% of the binary star systems in our universe. The final system is called a contact binary. In a contact binary, both stars are so close and overflow their Roche lobes to such an extent that they appear in a single dumbbell shape that spins on an axis. Over time, a huge atmosphere of plasma and matter appears around these stars called a common envelope. These are very rare, but could play into the future of humans colonizing other planets. Finally, asteroid fields. The asteroid fields in Star Wars are shown as being huge and extremely dense areas filled with rock that only the most daring pilots could traverse. To put this into context, let us explore our asteroid belt between Mars and Jupiter. As of the most recent estimate, scientists estimate that there are over 2 million sizable space rocks in our asteroid belt. With this in mind, it may seem as if the science fiction films weren't far from the truth, but in reality, the asteroid belt is immense. And in fact, there is on average 1 million kilometers between each sizable asteroid. To put that into context, if we put all of the asteroids in our asteroid belt together, they would be no larger than the moon. In this light, we can clearly state that the Star Wars films were not scientifically accurate. So, in conclusion, the elements of the Star Wars films are often not scientifically accurate. However, some technologies like plasma weaponry and human settlement onto binary star systems could play into the future of humanity. Thank you.